talk about today. All right? What is density? Does anybody know what density is?
Is it the amount that it takes up, like in space?
It deals with the amount. It's something per the amount of space it takes up.
Isn't it the amount of matter in a certain space?
Yes.
Right, that's what
Matter's that's the more specific word I'm looking for. All right, it's the amount of matter per a given unit of volume. Where have you heard density before when you think of whether or not something does what on water? Floats. If it's more dense, what does it do? Sinks. If it's less dense, it floats. All right, so what is density? You have a long definition, and then you have a short definition.
Which one do you prefer?
Both of them say the same thing. One's just more drawn out in case you don't understand the second one. All right, so it's how much space an object or something takes up. All right, how much space is volume. So it is the per volume, how much space it takes up in relation to the amount of matter that's in that space. All right, the amount of matter is its mass. So essentially mass per unit volume. Your top definition just has mass and volume defined for you as well. Think about this. If you have a bag of bricks and a bag of feathers, and both of those bags are the same size, all right, they have the same volume, which one's heavier? The bricks, because how much more is packed into like that bag? Think about a brick and how tightly packed together it is. Is there any space really in it? No, it's all packed together tightly. There's a lot of mass in that same amount of volume compared to that bag of feathers. And are they as tightly packed? No, there's a lot of air. It's really thin, right? So those feathers have less matter packed into that same space. I see some of you writing. I'll give you a few seconds. All right. Density formula. Density is going to be mass divided by volume. So we said is the amount of mass that is present per unit of volume. Mass per volume. So mass is mostly measured in grams, and volume is typically going to be measured in milliliters or centimeters cubed. Depending on what somebody's measuring the density of, sometimes you'll see liters, sometimes you'll see kilograms. So it kind of depends what somebody's measuring the volume of, what the most standard unit is going to be. But what you're going to see the most is grams per milliliter and grams per centimeter cubed.
What would you label density as?
D.
But I'm just saying
Good question. So if it is mass over volume, that's a great question. What is the unit for mass? Density is grams. What is the unit for volume? One of them could be milliliters or grams per centimeters cubed. All right, do you see where we get that unit from? All right, you literally just keep the units from your mass and the units from your volume and put them together. It's saying I've divided the grams by the volume and I got my density. Great question. All right, so hopefully you all have seen this handy-dandy little triangle with basic equations. How many of you have seen it before? A few of you? All right, so whatever you are solving for is what you cover up. So if I'm solving for density, I get to cover it up, all right? And I see mass over volume. If I'm solving for volume, if I'm solving for volume, cover it up, and I can solve by mass divided by density, right? That's how if you algebraically rearrange this, it will give you mass divided by density, it gives you volume. Then, if I want mass, I'll do density times volume. So if it's at the top, divide. If it's side by side, multiply, right? And you can see that for here, for instance, if I was solving for mass, what would I do? This is at the bottom. I need to multiply both sides by volume. Multiply by volume. These cancel out. So volume times density equals mass. All right, so that just rearranges it for you. If it is easier for you to algebraically rearrange it and you're good at math, awesome, go for it. All right, whatever makes most sense to you. Gentlemen online, do you understand how the triangle works?
Yes, ma'am.
All right, awesome. So let's look at, you've got some example problems, and then we'll get started with our lab. So, number one, what is the density of a 6.2 milliliter, this is my what? Milliliters measures volume. Solution weighing 13 grams. Grams is? Mass. All right, so density equals mass over volume. Our handy dandy little triangle tells us I have density, mass, volume. Right, so I'm looking for the density. I have a mass of 13. I can plug it in now. And a volume of 6.2. Somebody divide that for me in your calculator. It's going to be 2 point something. 2.09677 grams per milliliter. What is important here? That's our answer. What have we been talking about last 2 days?
Labeling.
It does have a unit, grams per milliliter. Rounding, but how do I know where to round? Based on? Sig figs, yes. All right, so how many sig figs does 13 have? 2. Remember, this is multiply, divide rule, so it's based on total sig figs. How many sig figs does 6.2 have? 2. So how many can my answer have? 2. So I'm going to cut it off right here. What does that 9 do to my 0? Rounds it up. So my density equals 2.1 grams per milliliter. Now I'm written in the right scientific number of sig figs. Questions? Are we good? Pretty simple, right? All right, what is the density of a 2-liter bottle? Liters measures volume of soda weighing 2.1 kilograms. Kilograms is mass. All right, so density equals.
Does it not have to, like, are they interchangeable, the two, like, the volume and the mass?
Yes, that's why your units are important. Elsewise, you don't know whether or not that's grams, kilograms, liters, right?
Right.
So, as long as we have our units to tell us what units it was measured in.
Wait, but then,
Wait, how do we
so
know
you don't
that
have to
that's-
convert it to grams because they're not the same, you know what I mean?
No, you could.
But like,
You could convert this to grams and you could convert this to milliliters.
oh, because it's still the same, they can just change the labeling at the end.
Right, it would change the labeling at the end. So whoever's reading your data would go, oh, okay, Molly measured in liters.
Right.
Or Molly measured in kilograms.
Okay.
Right? If Annie did it, you'd have, oh, wait, she measured in milliliters.
Right.
Right? So, good question. So, density equals mass over volume. Our mass is 2.1. And then our volume is 2. 2.1 kilograms. 2 liters. And that's going to give me density. So, if we divide that, what do we get? 1.05. 1.05. So density equals 1.0. Is it 05?
That's what I thought.
Yeah, I got both of them.
All right. 1.05. Does it continue on?
No.
All right. And then it is kilograms per liter. All right.
Wait, so do we know from that chart you gave us, the first notes, like if it's mass or volume?
Yes.
Okay.
Because your units. Liters always measures
Volume,
volume. Grams always measures
mass.
mass.
Would the word, like the word weigh in front of it, help you? In any way?
Yeah, it could. Like this one says the density of a, like the one before this. What's the one before it? There's one that says it has a volume of X amount of milliliters. So then, yeah, you can always use the words in front as a cue. All right, 1.05 kilograms per liter. And then this is our multiply divide rule. So it's based on the total number of,
Same thing.
total number of sig figs. This one only has And this one only has? So, the fewest amount of sig figs here is 1. So I'm going to cut it off right here. Does that 0 change my 1 at all? No. So with the appropriate amount of sig figs, I have 1 kilogram per liter is my density. All right, let's look at the next one. A machine worker records the mass of an aluminum cube to be 176 grams. So, Andy, that's what you're talking about. Look, it says it records the mass. So mass lets you know, hey, that's what this is telling me.
Okay.
So there's an example of that. If one side of the cube measures 4 centimeters, what is this?
One side.
It's one side. It's the length, right? It might be the length, width, height. It's a cube. What is the density of the cube? So I'm looking for density. I know that D equals M over V. So let's plug in what I have. All right, density. And then I have a mass, 176 grams. But do I have a volume?
Not yet.
No, not yet. All right, Wade, so how could I find this since it's a cube and I know one side of it?
You multiply 4, like 4 times 4 times 4.
4 times 4 times 4. Good job, Wade. All right, because length times width times height, length, width, height is going to give me the volume, all right? Equals volume, and it's going to be in centimeters cubed, right? Because centimeters times centimeters times centimeters. So somebody do 4 times 4 times 4 and tell me what you get. 64. So then I get, I'm going to write it here so I can see it for anybody who has questions. 64 centimeters cubed. So right here, 64 centimeters cubed. All right, so this is where you were asking, does it matter, right? So now we have centimeters cubed. That's why it's important, because when I write my answer, I know what it was measured in. All right, so divide, and what do you get? Density equals
2.75.
2 point, hoping that's what I was looking for. Density equals, it didn't change. 2 point what?
75.
Grams per centimeter cubed. All right, if I look at this, least amount of sig figs, how many does 176 have?
3.
64. 2. All right, so that means the most my answer can have is
2.8.
2. So I'm going to round it up, correct. All right, Sam, to what?
2.8.
2.8. That 5, rounds it up, 2.8 grams per centimeter cubed. All right, what did y'all say the key was? 4, what was the little reminder cue? Something, leave it be.
4 or less, let it rest. 5 more, let it soar.
4 or less, let it rest. 5 or more, let it soar. So 5 men or 7 soar to number 8. All right, questions? Good?
Yeah.
All right, gentlemen online, are you good? All I heard was the Is that a yes?
Oh, yes, ma'am. Sorry.
All right, awesome. All right, so calculate the volume of a liquid with a density of 5.45 grams per milliliter. So again, Annie, there's where you see it gives you the density. So it says density of, in case you looked at those units and forgot what the units for density are. And then a mass of 65 grams. So mass, density equals mass over volume. When I plug it into my triangle, my mass is 65 grams. My density, 5.45 grams per milliliter. And so, Molly, what does that mean my volume is going to be measured in? Milliliters, yes, because we see right here, if density is by units of milliliters, then our volume will also need to be in milliliters. So what do I find my volume to be?
Would you divide the density or by mass or with mass by density?
Whatever's on top gets divided by what's on the bottom. Good question. So 65 divided by 5.45. Somebody that's punched it in.
0.0838446.
83846. All right. Milliliters.
Sorry, point. Oh yeah, that's
Wait,
right.
65 divided by 5.45.
Yes.
Oh wait,
I got 11.
11.
9.
Oh yeah, it's definitely not a. Sorry. Go ahead. Did you? Yeah, I think you did it the other way.
yeah, I did 5.45 divided by.
11.9266.
11.9266 milliliters. Least amount of sig figs up here I have 2. Down at the bottom I have 3. When I think what you did was 545 divided by 65.
Yeah, but why? Can you explain why it's? Because isn't 65 the mass and then that's
Yes. So mass always goes where?
on top?
Up top, and density is going to be at the bottom. So if we look at it algebraically, you have 5.45, all right, equals 65 over volume. In order to solve for volume, I need to get it out of the bottom. Multiply by volume, multiply by volume. And so then that leaves you with 5V equals 65. And so then how would you solve for V?
You divide by 5.
Yep. So do you see how that switches it around?
Yes.
All right. And then that's when you get your 11.9266. Good question. So 2 sig figs, 3 sig figs. How many can I have in my answer? 2. Good job. So that means I have to cut it off right here. Pacific, I'm coming from the left this way, and my 1 are my 2 sig figs. What does this 9 do? Rounds it to 12. So 12 milliliters is my volume. All right, and last one. I see some of you working ahead. Great job. Make sure you're stopping if you have questions. 23.5 milliliters is what? Volume. So we did a demonstration and it displaced the water by that much. What does displacement mean?
That's how much it took up.
Yep. So you drop that substance down into water that you already knew the volume of, and you measure the change in volume. So that piece of cork that you dropped in weighed 5.7 grams. So what is our density? Density equals mass over volume.
5.7
Yes, good job. 5.7 over 23.5. And then we get a density of
0.24. 2553.
0.24253. All right, awesome. So that's grams per milliliters. Am I done yet? No. All right. You have got to find our sig figs. So up here, 2 down here. Great job. All right. So rounding it off to 2 sig figs. So 0.24, right? 4 or less, let it rest. Right? Grams per milliliters equals my density. Any questions? All right, awesome. Got about an hour for your lab.